Dear students, welcome to Maths second sem class. In previous class, we discussed the hyperbola and its elements. When equation is given, then we knew how to find its elements. And today we will learn some more problems on hyperbola. So today class objectives. On completion of this period, you would be able to write the equation of the hyperbola when different elements are given. In previous class, the equation is given and asked the elements, and today it is reversed, asking equation and given elements and different elements. Based on the elements conditions, we have to find equation of the hyperbola. So recap. What is the equation of hyperbola with focus at x comma y? Ax plus by plus c equals to 0 as directrix and eccentricity E. So focus, directrix and eccentricity, these three elements are available. Then we know the formula for the equation of hyperbola, that is x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c whole square by a square plus b square. And this is the formula to common for three elements, that is parabola, ellipse and hyperbola. So this is the important and very common formula for the three conic sections. Here the brackets are missing for x minus x1 and y minus y1, so we have to kept it in bracket. Now let us see the questions or problems of the hyperbola. So question number 1. Find the equation of the hyperbola whose focus is 2, 1. Directrix is the line 2x plus y minus 1 equals to 0, and eccentricity is root 3. So focus, directrix and eccentricity are given, and asking the equation of the hyperbola. So the solution is given that focus is at s2, 1. Equation of the directrix is 2x plus y minus 1 equals to 0, and eccentricity E equals to root 3. We know that the equation of the hyperbola with focus at s x1 y1 comma ax plus by plus c equals to 0 as directrix, and eccentricity E is, therefore equation of the hyperbola is x minus x1 whole square. Here bracket is missing, so we have to kept the x minus x1 in bracket, and same for y minus y1 also. So kept the bracket to y minus y1 also. Y minus y1 whole square equals to e square into ax plus by plus c whole square by a square plus b square. The square we split for numerator and denominator. The denominator square root get cancelled. We have then a square plus b square. And so in the formula substitute the focus at x1 comma y1 and eccentricity value and directrix values. So the equation is x minus 2 whole square plus y minus 1 whole square equals to root 3 square into 2x plus y minus 1 by under root 4 plus 1 whole square. So now if we expand, we will get 5 into this 5 is came from the right side term. The right side term denominator 5 is there, so if it comes to left side, it is multiplied with the left side terms. So 5 is common for left side term, so 5 into bracket open, and if we expand the x minus 2 whole square, like a square minus 2ab plus b square, then we have x square minus 4x plus 4, and similarly y minus 1 whole square means a minus b whole square, that is a square plus b square minus 2ab, that equals to 3 into root 3 whole square means 3, and 3 is multiply with the 2x plus y minus 1 whole square, so it is also we have to expand, so it is in the form of a plus b minus c whole square. A plus b minus c whole square equals to a square plus b square plus c square plus 2ab minus 2bc minus 2ca. So here wherever c comes in that term, we have minus. So 3 is common for whole this expansion. That's why 3 is kept outside before the bracket. That is means 3 is multiplied with the all the terms which are in the bracket. On simplification, we get the equation of hyperbola as 7x square minus 2y square plus 12xy plus 8x plus 4y minus 22 equals to 0. So if focus, directrix and eccentricity is given, then it is easy to find us because we have the formula and substitution in that formula. If we substitute and simplify, we will get the equation of the hyperbola, and this formula is used in both the parabola and ellipse also. So this is the common formula for the three conic sections, that is parabola, ellipse and hyperbola. In parabola, eccentricity is 1, so it is need not to write, but whereas ellipse and hyperbola we have to write and substitute the eccentricity what is given in the question or data. Now second question, find the equation of the hyperbola whose foci at plus or minus 3 comma 0 if the eccentricity is 6. See here, foci means plural form of focus, so that is two focus points are given. One is 3 comma 0 and another one is minus 3 comma 0. Both are together at once, so that's why it is given plus or minus 3 comma 0. If the eccentricity is 6, so here eccentricity and focus points are foci given. So by observation we can say transverse axis is along with its x-axis, because foci is indicating the abscissa and ordinate is 0. So from focus and eccentricity we will get the a value, and after a and eccentricity we get the b value, then we can know the hyperbola equation. So by observation we can say it is nearer to first form or second form. Mainly it is in the first form, because the foci is if we observe ordinate is 0, that means transverse axis is along with x-axis, so the center is 0 comma 0, so it is a first form. We can say that is x square by a square minus y square by b square equals to 1. So in this form we have to know a value and b value. So let us see how to find a value and b values from the given elements. Solution: given that foci equals to s plus or minus 3 comma 0 and eccentricity equals to 6, that is foci is we know first form, it is plus or minus a comma 0, that equals to plus or minus 3 comma 0. So if we compare, abscissas are equal, that means a equal to 3 E value 6, so write 6 at E. So A into 6 equals to 3. Then A equal to 1 by 2. So we have now A value, that is 1 by 2. Then A square equals to 1 by 4. For a hyperbola, B square equals to A square into E square minus 1. From eccentricity, we can build this equation or formula, that is B square equals to A square into E square minus 1. So substitute the A square values and E square values, then we get like this: B square equals to 1 by 4 into 36 minus 1, and B square equals to 35 by 4. As y coordinate of the foci is 0, transverse axis is along x-axis. Hence the required hyperbola is x square by A square minus y square by B square equals to 1. X square by 1 by 4 minus y square by 35 by 4 equals to 1. That is 4x square minus 4y square by 35 equals to 1. So this is how we get the equation by given elements. And we see the next question, question number 3. Find the equation of the hyperbola whose center is 0, 0. Distance between the foci is 8. Distance between the foci is 18, and the distance between the directrices is 8. See, the equation of the hyperbola whose center is 0, 0 means the equation is either in the first form or second form, because they have only center 0, 0, and remaining two forms contains center is other than 0, 0, that is h, k, or 1, 2, 2, 3, any numbers. So only first two forms indicates or contains center as 0, 0 or origin. So now we have to fix either it is first form or second form. From these two forms we have to choose. To choose, we have to know the values of A and B. Then we can fix which form it is. let us see the solution. Given that center is at C 0, 0, distance between the foci is SS1, that equals to 2 into AE, that equals to 18, that is AE equals to 9. Distance between the directrices, it is ZZ1 equals to 2A by E, that equals to 8. So that implies A equals to 4E. So consider it equation number 2. And distance between the foci, that is A equal to 9, consider it equation number 1. From 1 and 2 we have 4A, A equals to 4E, and in the equation 1 A equal 9. So in place of A, write 4E and E equals to 9. So E square equals to 9 by 4. So A square equals to 16 into E square. From equation 2, A square equals to 36. To find B square, we have the formula, that is B square equals to A square into E square minus 1 for a hyperbola. So that equals to 36 into 9 by 4 minus 1, that equals to 45. Therefore, the required hyperbola is x square by A square minus y square by B square equals to 1. So x square by 36 minus y square by 45 equals to 1. So here A value and B value, if you know, then you take the form as a first form and substitute so that we get the equation of the hyperbola. Next, number 4, problem number 4. In third problem, we are not selected, or we are not chosen from the two forms. We taken first form because there is need not to choose, because according to the data we are getting A value and B value. So it is enough for the find hyperbola equation. We can know the first form, and in the first form if we substitute we will get the equation. So that is need not to select or fix the form of the equation among the first two forms. So if you know the A value, B value, then take first form and substitute. Next here another question, that is question number 4. Find the equation of the hyperbola and length of latus rectum whose center is at the origin, whose vertices are the points plus or minus 2 comma 0 and foci are plus or minus 3 comma 0. So here the elements are given and some condition is also given, that is find the equation of the hyperbola and length of latus rectum. So they are asking the equation and element, and condition is whose center is at the origin. So center is origin means it belongs to first form or second form, but when we come through the data we can fix it is a first form, whose vertices are the points plus or minus 2 comma 0 and foci are plus or minus 3 comma 0. So ordinates are 0 means it is we can fix in the first form. So to know the first form or to write the equation, we have to know the a value and b value. So from the elements or from the points we will find, and then we know the equation and also length of latus rectum. To know the length of latus rectum we have to know a and b values. Let us find solution. Given that center is at C 0 comma 0, origin means 0 comma 0, vertices at A plus or minus 2 comma 0, that equals to A plus or minus A comma 0. So A equals to 2, that implies A square equals to 4, and foci at S plus or minus 3 comma 0, that equals to S plus or minus A comma 0. So A equals to 3, E equals to 3 by 2. To know the B, we have formula of the E square. From the E square we can get the B square formula, that is B square equals to A square into E square minus 1. So substitute the A and E values and simplify, we get 5. So B square equals to 5. Length of latus rectum equals to 2b square by A, or 2 into b square by A. So 2 into 5 by 2, so that equals to 5. Therefore the hyperbola with center at C 0 comma 0 and transverse axis along x axis is x square by a square minus y square by b square equals to 1. That is x square by 4 minus y square by 5 equals to 1. Summary. In this session, you have learned problems on hyperbola. So different elements are given and we found the equations according to the elements or conditions. And not only equations, we are find some other elements also, like length of lattice rectum. So the basic thing is from the given elements we have to find a value, b value. For third form we have to find h and k value. So when these we will get, we can substitute in the form and we will get the equation. So very simple, and we have to remember the AEB relation, that is b square equals to a square into e square minus 1. This is the for hyperbola AEB relation. So if we know the two values, then by using this formula or this relation, we know another value. Questions from previous papers. Number 1. Find the equation of a rectangular hyperbola whose focus is at 1, 2. Directrix is the line 3x plus 4y minus 5 equals to 0. So a rectangular hyperbola means the eccentricity is root 2. So here indirectly eccentricity is given and focus 1, 2, directrix 3x plus 4y minus 5 equal to 0. So these three elements are given, means we can find the equation easily because we have a formula or common formula, that is x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c whole square by a square plus b square. Number 2. Find the eccentricity of the hyperbola whose foci is at 5, 3. Foci at, because it is a plural, comma minus 3, 3. So foci are, we can say 5, 3 minus 3, 3. And eccentricity is 3 by 2. So here foci is given in the abscissa and ordinate, and foci we can say that is A, but here ordinate is also there, so h plus r minus AE. So h plus a equal to 5 and h minus a equal to minus 3 comma k. So k equals to 3. So that is we can say it is related to third form. So h plus r minus a comma k, k equal to 3. So h plus r minus a, h plus a equal to 5. We know the e, then we get h value and a value. So after that we know the b value, then we will substitute in the third form, that is x minus h whole square by a square minus y minus k whole square by b square equals to 1. Next, third question. Find the equation of the hyperbola with center at the origin, transverse axis on the x-axis, eccentricity is 2, and length of lateral rectum is 18. So it is first form. So length of lateral rectum is given, so 2b square by a equal to 18 and a equals to 2. So b square is expressed in a, that is a square into e square minus 1. Then e value we know, so total equation comes in a, and if we simplify we get a. Then e and e means we know b also. So a, e, b we know means ab is enough for now to get the equation. So we can easily find. Next question. Find the equation of the hyperbola with center at minus 1 comma 2, one of its foci at 3 comma 2, and corresponding vertex at 0 comma 2. Center at minus 1 comma 2 means it is belongs to third form or fourth form. So from third and fourth we can take third form, and one of the foci, that means focus is given, that is 3 comma 2. So center h comma k means h value minus 1 and k value 2. Foci means we can take h plus ae equal to 3 and k equals to 2. So vertex at 0 comma 2 means we can take b value is 2, so our a value is 2. So by vertex we can say it is fourth form. So fourth form equation is y minus k whole square by a square minus x minus h whole square by b square equals to 1. So here 0 comma a is the vertex, so a value 2, and we find b and h comma k h comma k from center we know, so we can find b. And to know the b, first we have to find e from focus, and then we find b. Then if we substitute a and b in the fourth form, we will get the equation. So this is the procedure to find the equation of the hyperbola. Assignment. So question number 1. Find the equation of the hyperbola whose foci are -2, 1, 8, 1 and e equals to 2. Foci are means two focus points given, that is -2, 1 and 8, 1. That means the center is not a origin, so it belongs to either third or fourth form. So it is a third form we can take, and h plus r minus ae, h plus ae equal to -2. Then we know the e value, and k equal to, we can say, 1. So h minus ae equal to 8. So from these two we can get a value, and then h value, and then b value. So finally we get the equation when we substitute in the third form. So the third form is x minus h whole square by a square minus y minus k whole square by b square equals to 1. Next question number 2. Find the equation to the hyperbola whose center is 0, 0 and distance between foci is 18 and distance between the directrices is 8. So based on center we can say it is the first form, and distance between foci means 2ae equal to 18, and distance between directrix equals to, we can say, 2a by e equal to 8. From these two equations we get a values and e values, then we get b value. Then if we substitute in the equation 1 or in the first form, we get the equation of the hyperbola. Next question. Find the equation of hyperbola whose center at the origin, whose axes are the axis of coordinates, and which passes through points 1, 2 and 3, 4. See here, whose center at the origin means it is either first form or second form, and whose axes are the axis of coordinates, and which passes through points. Here 2 points are given, means first we have to take the first form and substitute the point in the first form in place of x1 and in place of y2, and then simplify, then we get equation in the form of a and b. Then same, we have to substitute the second point, that is 3 comma 4. Then we get another equation, that is in the form of AB. We consider it as a 2 and solve 1 and 2 to get A and B values. So we will get A and B values from two equations. Then if we substitute in the first form or taken equation or assumed equation first form, we will get the equation of the hyperbola. Fourth question here, the foci of a hyperbola coincides with the foci of the ellipse. See the another question. The foci of a hyperbola coincides with the foci of the ellipse. X square by 100 plus y square by 64 equal to 1. Find the equation of the hyperbola if its eccentricity is 2. See, the foci of hyperbola coincides with the foci of the ellipse equation given. From the given ellipse, we have to find foci, and that foci is we can take as a hyperbola's foci, because in the question coincides with the foci of the ellipse. So we have to find the foci from this equation, and then it can be taken as a hyperbola's foci. Then we can find easily a value and then b value. Then we can find the equation of the hyperbola. So this is the procedure or method to find the equation of the hyperbola with given conditions or different elements. So not only these assignment problems, some more problems are given in our textbook question, in our textbook. So some questions are in the textbook, so do that problems also, exercise problems. And while you are doing, if you have any doubt, you can ask me or call me, or you can message me on WhatsApp. I will tell you and I will explain you in next class also. We will discuss in that next class also what are the doubts you are getting while doing the problems. We can discuss and clarify. I will clarify your each and every doubt. And most of the problems are similar to example problems. So first understand the example problems and then start doing exercise problems. So this is the method how to find the equation of hyperbola. So practice and do the questions, and remaining we will discuss in next class. Thank you.